Okay, so this is basically your hour. Let me just blab for a few moments, and then I'll let you ask stuff. All right, so we're here. I've covered everything I need to cover for just the 3 sections. So tomorrow's a test. You know all the rules about the test by now. I don't think I have to repeat them, so I'll just say very little about that. So as usual, I'll send by Canvas announcements around 9:01, 9:02 the exam, but I also project it. Some of you prefer the projection method. You have to submit the homework, which is not that much. 70% requirement. What do? I do half of it, 1/3 of it, sometimes more than half, so you don't really have that much to do. Okay, how many questions? I still plan to give about 10, maybe more, maybe less, but we'll see how it goes. Okay, then after that, we just have 4 sections left, and we'll have, I'm going to say 2.5 weeks. We have 3 weeks, but next week there's only 3 days because of Thanksgiving. I'm still going to aim right now for Thursday, December the 10th for the last regular test, so then Friday I'll save for review. Now, that doesn't necessarily mean I'll have the exams finished for you by the next day, since it's only a next day thing, but I should have it back to you, sometime the weekend. And then again, the final exam is Monday the 14th, 8:10 to 10:40. And you say, how do I study for the final exam? Just study the previous exams, and that should be good enough for that. Okay? All right, so you may either put questions now on the chat, or if you want to unmute yourselves and say what you want, you can do that too. I have to kind of bounce back and forth between sharing the screen and looking at chat. I did find out a way to check the chat under this method, so let me see that. Okay, so I have 5.3, 9, 29, 41, 59, 57, 29 was already asked for, 21, 5.43. Okay, so let me try to read it. And 9, 29, 41. And sometimes when things are going, it's sort of nice if I had a, TA or somebody who could check this for me, because while I'm teaching and lecturing, I might make a mistake here and there. So if you find that I missed your question, then just go ahead and put it again, or unmute yourselves and put it one more time. Okay, I have 1, 2, 3, 4, 5, 6, 7 problems to do now. And if I miss it, I apologize. Things are moving so fast, I can't necessarily see everything. So just ask again, or you're going to mute yourselves for that. Okay, so I'll get started now. Okay, so 5.3. And get my calculator handy. Hopefully everybody knows how to use the E and the LN buttons, right? All right, so here we go. 5.3, number 9. 5.3, number 9. Log base 2 of 1/8. Okay, so first I would call it X. Unscramble it. Unscramble it means start with a base. You go across the equal sign for the exponent, which is X. Come back in for the result, 1/8. Okay, so it's always base, across the equal sign for the exponent, come back in for the result. Okay, let me write this as base 2, since this is already base 2. 1/8 is 8 to the negative 1. 8 is equal to 2 cubed to the negative 1. Right, so that's still 8, right? And now I have a principle from exponents that if I have a power of a power, I multiply these. Okay, and now when you get a situation like this, 2 to the something, 2 to the something, the two somethings have to be equal. So X equals negative 3. Okay. It's not really even math. It's like this. 2 exponent, 2 negative 3. Maybe this better be negative 3, right? It can't be negative 4. It can't be 7 or something like that. Okay, so that's basically it for that. Okay, 21, same section. So I got a flurry of questions from 5.3, so let me stick to that for now. So 21, ln 2x cubed over x plus 4 squared. Okay, so this is the ln of a quotient. That's the difference of the logs. And if you haven't already done so, put it on your cheat sheet, on your formula sheet for tomorrow. So ln, and actually this is a multiplication here, 2 times x cubed, so ln 2 plus ln x cubed, right? And since this is a division, it's minus ln x plus 4 squared. And now all the exponents come down. That comes down, that comes down. By the way, on the test tomorrow, you don't have to draw these arrows if you don't want to. I mean, you may, I'll let you, but for teaching purposes, I put it in case you're wondering, where did that 3 go, right? So I tell you, oh, I put it in front, put it in front. But you don't have to do it for me if you don't want to. But you may if you wish. I'm not requiring you to. 3 ln x minus 2 ln x plus 4. Okay, so that's 21. Again, on days like this, I'm aiming more for quantity rather than quality. Sorry. So, you know, in order to answer all the questions, I might have to go fast. But again, the nice thing about it is this is being recorded. You can always play back the video. And of course, when you have once you have a video, you can fast forward, back up as much as you want, pause, rewind, etc. Okay, let's see, 29. You can still put stuff in the chat. I can't read it right now, but I'll get to it eventually, hopefully. Okay, 29. We're going the other direction. Put it together. So 1/2 ln x minus 2 ln x minus 1. Okay, so the idea here is you take the exponents from the coefficients. So the coefficients climb back up. You go the other direction. So those laws of logs, they work both directions, right? Page 298. Remember, you might be going left to right, but you might be going right to left also. So don't say, oh, it only goes from left to right. No, you could go from right to left also. So be ready to go both ways. I highly advise you to put this on your cheat sheet for the test tomorrow, or you know, my equivalent version, which I thought was a little bit cleaner. But you know, this is fine too. So these climb back up. Minus ln x minus 1 squared. Right as a single log. And there's a minus. Minus means divide. Okay, I'll write this as a square root. That's the way it normally should be written, right? Something to the 1/2 power of the square root. So final answer, ln square root of x over x minus 1 squared, like that. Okay, 9. Let's see, what else was asked for? 41 looks like. Whoops, I lost my page. Okay, solve for x. Natural log of 2, whoops, plus natural log of x plus 1 equals ln 4x minus 7. Okay, there's an addition here. It's a sum. So I'll take the ln of the quotient, product rather, that times that. ln 2 times x plus 1 equals ln 4x minus 7. And how do I get rid of an ln? E. Cancel, cancel. Once you get to this, you know it's very comfortable, right? It's just a linear equation. Let me distribute 2x plus 2, 4x minus 7. Subtract 2x. 2 is equal to 2x minus 7. Add 7. 9 equals 2x. Divide by 2. X equals 9. 2. quick double check. Am I taking the log of a negative or 0? If I put 9 over 2, that would be 18 minus 7. That's okay. That's positive. That's positive. Okay, we're good. Okay. Remember, you can only take the log of positive quantities. Okay, so if you end up taking the log of 0 or negative, you have to throw that solution out. Okay, 41 is done. 57, 59. Okay. Seven. Y equals 2 minus log base 2 x minus 1. Okay, so this is another one of those where you might have to draw several graphs. It's up to you if you want to put them all in the same graph, but sometimes if you do too many in one, it gets all cluttered up. So let's see if I have enough colors here. So I'll start with the basic log function. So basic log functions all look like this. So log 2x, 1, 0. Okay, then how about move 1 to the right? So let's see, if I move 1 to the right, 1, 0 becomes 2, 0. Switch colors here. 2, 0. Same general shape. Log base 2 of x minus 1. Okay, now I want to put a negative in front of it. So let me do blue. Okay, what does the negative do? The negative reflects across the x-axis. So this part that's above is going to bounce down here. Still going to go through 2, 0. Log base 2, oops, negative log base 2, minus 1. And then this part that's below bounces over to here. Like that. And finally, this moves the whole thing up to, in my opinion, the picture's getting too cluttered now, so let me make a new coordinate system. And by the way, you can do likewise on the test. If you want to put your progression all in one graph, that's fine, but if you want to use separate graphs, just like the last quiz, right? Remember the last quiz I said, okay, if you want to put them all on the same graph, or put them all in separate, or put 2 on one and 3 on the other, or whatever. In my opinion, the picture's getting too cluttered now, so I just make up a new graph. And let's see, now I just shoved the whole graph 2 up. So 2, 0 becomes 2, 2. Okay, that's all I'm going to do. So what am I trying to do? I'm trying to draw the same graph as this blue one and move 2, 0 up to 2, 2. And then draw the same basic shape as that. So now that's my final answer. 2 minus log base 2 of x minus 1. Or think of it as negative log base 2 of x minus 1 plus 2, which is essentially the same thing. Okay, then the last one I see, at least from this batch, was 59. Oops, I didn't want to use red. That's okay. Okay, where's 59? Y equals 2 ln x plus 1 minus 3. All right, so a similar theme. I start with my ln. Let's see, move 1 to the left, double it, and then down 3. Okay. So let me do a progression again. Now it's kind of crooked. Anyway. ln x, 1, 0. ln x plus 1, move 1 to the left, so 1, 0 becomes 0, 0. Ln 1. Multiplied by 2. Okay, so that's going to be higher on this side, lower on this side. So the picture's already getting kind of cluttered. 2 ln x plus 1. It still goes to 0, 0. And then take the red one and move it down 3. So 0, 0 becomes 0, negative 3. Okay, so again, in my opinion, it's better to just start with a brand new graph for the final answer because the picture's getting too cluttered. Now, if you're doing something similar to what I'm doing in the test, show me everything, right? So don't just show me the graphs. Do like I'm doing. This is ln x. This is ln x plus 1. Don't make me guess. Now, is that your original and that's 1 to the right or whatever? So don't make me guess which is which. You're telling me this is ln x, this is ln x plus 1, this is 2 times ln x plus 1, and so on. And now for my final answer, I just move the graph down 3, which means 0, 0 becomes 0, negative 3. Then I try to draw the same thing as the red one. So there we go. 2 ln x plus 1 minus 3. And while I'm at it, I might as well draw the asymptote, which is x equals negative 1. So the asymptote used to be the y-axis. Now it's over here. Okay, at least for the first batch, that was it for 5.3. So somebody asked for 5.4, number 3. I think I do see some people put some more in the chat. That's fine. 5.4, number 3. Let's see what that one's about. Okay, the bacteria in a culture increased from 500, that's your A0, initial amount, to 4,000 at 6 p.m. Okay, so the experiment begins at 1 o'clock, that's considered t equals 0. 6 o'clock means time is 5. Okay, find the number, blah, blah, blah. Okay, so let's answer all of those. So I'm using the formula A of t is A0 e to the kt. Well, I shouldn't have used red there, but anyway. Starts off with 500. Okay, experiment begins at 1, so 6 o'clock will be 5 hours, so I plug in 5 for t. The new amount was 4,000. Okay, solve for k. Divide by 500. 8 equals e to the 5k. ln, these guys cancel out, as you know. ln 8 equals 5k. Divide by 5, divide by 5. K squiggle equal. Okay, natural log of 8 divided by 5. 0.415888. And a bunch of other stuff. Okay, so A of t is A0 was 500, e to the 0.415 t. Okay, that's part A. Part B, 7 p.m. 7 p.m., I plug in what? The experiment starts at 1 p.m., so I plug in 6. Right? Part B. T times 6. Answer is so many bacteria. So bacteria population round to the nearest whole number. So let's see, what do I get? Take my answer multiplied by 6 and exponentiate and multiply by 5,000. 60,629 roughly. C, when will the population reach 15,000? So 15,000 is the new amount, so 15,000 goes here. Okay. So it's going to be 15,000 equals blah, 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 blah. So 15,000 equals 500 e is 0.4158888 t. Divide 500. Divide 500. Cancel, 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 cancel. 150 divided by 5 is 30. Equals space, e to the 0.4158888 t. ln both sides, right? These guys cancel out. Natural log of 30 is 0.4158888 t. Divide by 0.415, etc. 0.4158888, cancel. T squiggly equal, and this is hours for now. Okay, natural log of 30, ln 30 divided by 0.415. 8.18. But strictly speaking, it says when. When means a time. Okay, so experiment begins at 1 o'clock. So I add 8.18. That's roughly 10 minutes past 8 hours. So that would be starting at 1 o'clock. 9 and 1/6 of an hour is about 10 minutes. So about 9:10 p.m. We have to say when. And then part D, double in size. Okay, so double in size. Started off with 500. You want to know 1,000, right? So 1,000 equals 500 e to the 0.4158888 t, because it's a double. Okay, so how long does it take to double, i.e., if you start at 500, when does it become 1,000? All right, so divide by 500, divide by 500. You should be very comfortable with this now, right? We've done this over and over and over. 2, leave a space, equals, leave a space, e to the 0.4158888 t. So you should know by now why I leave a space here, why I leave a space here, right? Natural log, natural log. So these guys cancel out. ln 2 is 0.415 whatever. T. Divide by 0.4158888. 0.4158888. That cancels out. And let's see, in this particular case, it says, how long does it take? So you don't have to give a time. I mean, a calendar time, like 9 p.m. or something like that. Okay, wherever you happen to be, how long does it take to double? So it's okay to just leave your answer at so many hours. Okay, so ln 2 divided by 0.41. Almost exactly 1 2/3. 1.66 hours. All right, so I think I've caught up with that list. Now let me go back and check the chat because I'm sure there were more. Okay, what was the last one I did? I did 5.4 number. Okay, so what else? 5.4, 9, and 15. Okay, 5.49, a couple of people asked that. Okay, so I got that. 15. Okay, and somebody asked for 5.3, let's see, 5.349. Why isn't the answer something? Okay, maybe I'll just go back and look at that, because right now I can't tell what we're talking about yet. Okay, so let's see, 5.49, a couple of people asked for, 5.415, and yeah, let me just go back and do 5.349, I think someone asked for. Okay. At the moment, I can't really tell what's being asked, so we'll see. Okay, so 5.415 and 19. On 5.4, so it's right there. 15, an initial investment of $10,000 is made in an account where interest is compounded continuously. If the investment is for $25,000 in 5 years, what is the required interest rate? Okay. Okay, so the new amount is $25,000. The original amount is $10,000. E to the K, and the time is 5 years. Okay, so what will be the interest rate, continuously compounded interest rate? Okay, divide by 10,000, divide by 10,000. That's 2.5 equals e to the 5k ln. You do enough of these, you can do it in your sleep. You know, you just do the same thing. Just getting your reps, as they call it. Yes, right? Your repetitions. Do something over and over and over again, and you kind of get the hang of it. Divide by 5, divide by 5. Punch it in the machine. ln 2.5 divided by 5. 0.1833 rounded off. 0.1833, which they would present to you as 18.33%. Okay, so we're talking about a bank rate. Interest rate is always as a percentage. So change the decimal to a percentage. And normally the percentage round to 2 digits to the right of decimal point after it's already changed to a percentage, which means 4 digits here, 4 digits here, because after you move over 2 spaces, then 2 digits here. Okay. 5 point. Let's see. Somebody asked for 5.419, but I don't think we had to do that one. So don't worry about that. Yeah. Well, it was just 1 to 16. So 19 does not fall into that category. So I'm skipping that one. 5.349. Okay, I think I see what's going on. So ln x comes in front, divided by ln 4. Right, okay. Yeah, as I mentioned before, this is the only way you can write the answer. It's not the same as ln 3/4. It's not the same as 3/4. So when you get an expression like this, ln something divided by ln something, then if you're typing it in your calculator, do exactly that. It's not 3/4. It's not ln 3/4. Why? Just try it and you'll see they're all different. Okay, now let me just do it. ln 3 divided by ln 4. ln 3 divided by ln 4. 0.7925 rounded off. Well, I know 3/4 is 0.75. Are these the same? No. Therefore, am I allowed to cancel ln, so to speak? No. And ln 3/4. ln parentheses 3/4. Negative 0.287, something like that. So is that the same? No, it's not. Okay. So the reason why it doesn't work is because it doesn't work. All right. So when you have ln 3 over ln 4, type it just like that. Don't change it. Don't like cancel ln's and say 3/4. Why? It doesn't work. Don't make it ln of 3/4. Why? It doesn't work. Okay. Same reason. All right. So I think I've caught up with that round. So let me check back the chat and see if there's anything more. Okay. So I just see 5.349. Okay. 5.4. Number 9, I did that one. 5.413. Okay. 5.413. I think we just did 5.49, didn't we? We didn't. 5.4, number 9. 13. Okay. I did 15, didn't I? Yeah, I did 15. Okay, so 13 is asked for, 9 is asked for from more than one person. 5.415, I got it. Yeah, the other thing, of course, when you put stuff in the chat, I have to make sure I didn't go back over something. Because if more than one person puts it, then obviously I'm only going to do it once. Okay, I think I'm good. 9 and 13, this round at least. 5.4, number 9, and 13. Okay, so I'm closing the chat. I won't be able to see it again. You can go ahead and keep asking. So, find the half-life of a radioactive substance. 220 grams decays to 200 grams in 4 years. Okay, so A of T is A0 e to the KT. So you're starting off with 220. That's here. The new amount is 200. It decays in 4 years. E to the K times 4. Okay, so first I figure out the K. Divide by 220, divide by 220. That cancels out. This reduces to 10 over 11, which I'm going to leave like that, equals E to the 4K. ln parentheses, that cancels out. ln 10/11 is 4K. Divide by 4, divide by 4. K squiggly equals negative. I already knew it's a negative. You say, how did you know it's already a negative? It's a decay, right? It doesn't grow with time. It goes down, right? 220 becomes 200. So I'm expecting the answer to be negative. So natural log of 10 divided by 11, and divide that by 4. ln 10/11 divided by 4. Negative 0.0238, something like that. 0.023828. That should be good enough. Use that. Okay, so take that and plug it back into K. k. Right? So A of t is 220 e to the k, negative 0.02388 t. All right, now what? It asks us for the half-life. So if I started with 220, half of that is 110. So I plug in 110 here, figure out the t. 110 equals 220 e to negative 0.0238828 t. Divide 220, divide 220. I already know that's a half. 0.5, leave a space, equals, leave a space, e to negative 0.02388 t. So sometimes you can tell this ln stuff, you might have to do it twice within the same problem, right? Just one same question, do this ln business twice. ln 0.5 is negative 0.0238828 t, divided by negative 0.0238828, negative 0.0238828. That cancels out. T squiggly equals. It's time. Can I have a fractional time? Sure. And I believe we're doing hours. Oh no, years. Yeah, problem 9 was in years. Okay, so my answer is blah, 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 years. So your time can be anything in the problem. Just make sure you read the problem. Am I doing years, minutes, seconds, weeks, whatever? Okay. So ln 0.5 divided by my answer, 29.09 years. Okay. And 13. $10,000 is invested in an account, returns 8% per year, compounded continuously. How long will it take for the investment to double and triple? Okay. 13A. Check quickly. A of t is 10,000. You're investing $10,000 e to the k t. Oh, they told me k is 0.08, sorry. 8%. Okay, part A, double. Double means put 20,000 here. Equals 10,000 e to the 0.08 t. Divide 10,000, divide 10,000. 20,000 divided by 10,000 is 2. E to the 0.08 t. Same old stuff. ln, cancel the ln and the e. Natural log of 2 is 0.08 t. Divide by 0.08. T is years. ln 2 divided by 0.08. 8.66. B, I'll just tell you what it is. Triple. So instead of putting 20,000 here, can you guess what I'm going to put? 30,000. Okay. So A of t equals 30,000. And everything else is exactly the same. So if you don't mind, I'll just abandon that problem. Okay. I'll just say etc. All the calculations are exactly the same. This is going to be 30,000. But divide, that's the same. ln, blah, blah, blah. Okay. Completely identical. All right. And then problem 5. Caught up with that. Okay. Problem 5, I would have caught up, so that might be right now. This next one I'm doing is the last one, unless anybody else has anything. Well, it's getting to be almost 10 o'clock anyway. Okay, let me close the chat window because it's getting in the way. The radioactive isotope thorium-234. Don't use the 234 in this problem. It's irrelevant. It names the thorium isotope. Okay. Has a half-life of 578 hours. Okay. So let's write down half-life 578 hours. Okay. To me, it makes more sense if they put it in days. I mean, 24 hours a day, that'd be what, 20-something days or whatever. But whatever. If a sample has a mass of 64 milligrams, find an expression for the mass after T hours. So A of T is A0, 64, e to the k t. So first I have to find the k. So half of 64 is 32. And that happens if I plug in 578. Divide 64, divide 64. 0.5 equals e to the 578k. ln. Ran out of space, so I'll go back up. ln 0.5, 578k. ln 0.5, 578k. Divide 578, divide 578. K squiggly equal negative. And this is a decay, so I know already that it's a negative. ln 0.5 divided by 578. Negative 0.001199. So A of t is 64 e to negative 0.001199 t. Okay, part B. How much will remain after 75 hours? Plug in 75. T is 75. A of 75, written as a function, 64 e to the negative 0.001199 times 75, squiggly equal so many. And the mass is in what units? Milligrams. Can we have fractional milligrams? Sure. All right. Times 75. Second function. Exponentiate the answer. Multiplied by 64. 58.50. And then part C, maybe that's all the time we got. When will initial mass decay to 12 milligrams? 12 is a new amount. That's the new A. So 12 is equal to 64 e to the negative 0.001199 t. Divide 64, divide 64. I don't know if this comes out nice, but I can make it divide by 4, 3/16. Is that right? Yeah, let me just leave it at 3/16 equals e to negative 0.001199 t. ln parentheses, ln cancels out. Natural log of 3/16 equals negative 0.001199 t divided by negative, etc. Negative 0.001199. Natural log of 3/16 divided by negative 0.001199 So T is so many, and the units are hours. All right, natural log parentheses 3/16 divided by negative point. Sorry, ln 3/16 divided by negative 0.001199, 1396.14. Okay. 14 hours. Okay, and yeah, normally we wouldn't present it like that. Just change it to days. 58.17 days. Or they might even say 2 months, approximately 2 months for that. Okay. All right, folks, we're out of time, and I think I've caught up with the chat, so that's pretty much about it. All right, everybody, so have a good day. Be ready for the test tomorrow. You can start submitting your homework anytime that you wish now, and I'll get it. Okay, see you tomorrow for the test. Okay, bye, everyone.